Hello students, welcome to our class and start our learning with Let's Learn. And our today's topic is Chapter 1 Laws of Motion. In this video, in this lecture, we will study the definition of the force, units of the force and the Newton's third law. In our previous lectures, we have studied the Newton's first law, Newton's second law of motion, Newton's first law of motion and Newton's second law of motion. And today we will study the Newton's third law of motion. In our previous lecture, we have found this formula F equals to ma by the Newton's second law of motion. F equals to ma, where m is the mass of the object and a is the acceleration. So force is we can say force is the product of mass and acceleration. Force is the product of mass and acceleration of an object. It's clear? Understand? So SI unit of force is Newton. The SI unit of force is Newton. Just see here in this formula, what is the SI unit of mass? Mass is measured in kilogram or gram. But in a SI system, mass is measured in kilogram. And A, the unit of A, acceleration is meter per second square. So what is the SI unit of force is kilogram meter per second square, and 1 kilogram into 1 meter per second square is equals to the 1 Newton. Understand? If we take the 1 kilogram into 1 meter per second square, then this is equals to the 1 Newton. So what is the definition of 1 Newton? What is the 1 Newton? 1 Newton force is equals to the 1 kilogram mass into 1 meter per second square. That means when the mass, the value of the mass is 1 kilogram and the value of acceleration is 1 meter per second square, then we can say this force is equals to 1 Newton. So let's see the definition. What is the 1 Newton? The force that is necessary to cause an acceleration of 1 meter per second square in an object of the mass 1 kilogram is called 1 Newton. Understand? It's clear? What is the definition of force? Force is a product of the mass and acceleration. SI unit of force is kilogram into meter per second square, and 1 kilogram into 1 meter per second square is equals to 1 Newton. So we can write the SI unit of force is Newton. So what is the definition of Newton? So right here 1 kilogram and 1 meter per second square is equals to 1 Newton. So if the force that is necessary to accelerate the object as 1 meter per second square of the mass of 1 kilogram in an object of mass 1 kilogram is called the 1 Newton. It's clear? So next is a CGS unit of force. CGS unit. So in a CGS unit, mass is measured in gram and A is the acceleration is measured in centimeter per second square. So the SI unit of force is gram into centimeter per second square, and 1 gram into 1 centimeter per second square is equals to 1 dyne. So what is the 1 dyne? Same definition as 1 Newton. So 1 dyne is the force that is necessary to cause an acceleration of 1 centimeter per second square in an object of mass 1 gram. In the Newton, in the definition of Newton, we take the 1 meter per second square acceleration in an object of mass 1 kilogram. But in the definition of dyne, we just take the 1 centimeter per second square is acceleration, and the mass is 1 gram. So it's called the 1 dyne. It's clear, student? Then next is a Newton's third law of motion. Just observe this picture. This is a rocket. The next picture, this is a recoil gun. And this picture is a weapons. In these three pictures, what you observed, student? Yes, here two forces apply simultaneously. Because of one force, let's see the example of rocket. Because of one force, here the fuel burns and the gases exerts in the outside, and so the rocket goes upside. Okay, so here two force. Because of the first force, the rocket goes upside, and because of the other force, the gas exerted outside. Understand? And then in the next picture, when we pull the knob of the gun, any gun, then the bullets goes outside of the gun, and the gun just slightly backside, slightly goes to backside. So here also two forces are applied. Because of the one force, this bullets goes outside, and because of the other force, the gun comes backside, or our hand comes backside. Understand? Then next, these weapons. Here two forces are applied. Because of the first force, this explosion materials goes outside from this weapon, and because of the other force, this weapon, you can see clearly, this weapons comes backside. This weapons goes backside. Understand? So what you observed in these pictures? In these pictures, we can observe no force or any force cannot, in nature, force cannot act as alone. Okay, in nature, force cannot act alone. The force is a reciprocal action between two bodies. Force is a reciprocal action between two bodies. If first object apply the force to the other object, if one object, just I draw the big diagram. This is first object and this is second object. When first object apply the force to other object, to second object, then at the same time this second object applies the force to the former object. So here two forces. First force F1 and second force is F2. The direction of the both forces are opposite. Understand? But the magnitude of this force are same. Understand? So these are the two forces that act simultaneously to each other, and this idea is expressed in the Newton's third law. This idea is expressed in Newton's third law. So let's see what is the Newton's third law of motion. The statement is every action force means the force of the former object. Every action force has an equal and opposite reaction force. Action force, if we say this is action force, so this F2 is a reaction force. So here two forces, action force, other is reaction force. Every action force has an equal and opposite reaction force which acts simultaneously. Understand? So what is the statement of Newton's third law? Every action force has an equal because here F1 and F2 are equal. Magnitude of the two forces are equal. Action force and reaction force are equal and opposite direction. Because the direction of both forces are opposite, which act simultaneously, because the two forces act simultaneously at the same time. Understand? So this is a Newton's third law of motion. And some important points here. Number 1, action and reaction are termed that expressed force. Here action and reaction are forces. Action force, reaction force. Understand? These force acts in pair. These two forces. So this acts in pair. One force cannot exist by itself. Third, action and reaction force act simultaneously. Both act simultaneously. When the action force acts, at the same time the reaction force acts on the former object. When action and reaction force acts on a different object. Here the action force F1 acts on this second object, and the reaction force acts on this first object. So the both force, action force and reaction force, acts on a different objects. They do not act on the same object. They do not act on the same object, and hence cannot cancel each other's effect. It's clear. So these are very important points. I hope you understood, student. Understood? If you have any doubt, you can comment, and using this code you can join the Google Classroom and to get the homeworks, solutions and notes. Thank you very much.